Good morning. So it's another e-learning day for Western Middle School students. It's Monday, February 11th, and I'm going to have you continue working on your Draw That Atom that we started on Friday. With the short class periods, I know that it was a lot to take in a short amount of time, and we were kind of rushed, and you've had the whole weekend to forget everything that we initially talked about. So I thought I give you the answers to the first side. All of the classes got through hydrogen, helium, and lithium. A couple of the classes, um, I was able to walk around and verify whether or not they got boron done correctly. So I'm going to go over the answers to the first side, and then your e-learning assignment will be to do the back side and then submit it to me for your e-learning assignment. All right. So let's do a review of how you get all the information and fill it out and then apply it to the atomic structure. Okay, so all the information is going to come from your periodic table of elements, and then your mass number is going to be protons plus neutrons. So in other words, if you know the number of protons, you can take the mass minus protons equals neutrons. So let's do some reviewing. Up here, the number that I give you up here is going to be your mass. So, sorry, trying to get it. There we go. Maybe that'll work. All right, so these are your masses. Helium, 4 is the mass, 7 is the mass of a single atom, all right? And then we're looking at boron 11 on this last one, so we'll come back to it. So how we got the atomic number was we got that off the periodic table, so you'll need your periodic table in front of you. We took 1 minus 1 because the atomic number identifies protons and electrons. So we take 1, the mass, minus 1, and that equals 0. Okay? And that's how we got the number of neutrons. If you look at hydrogen on the periodic table, it's in period 1 and group 1. So that's how we got this information right here. So the period number tells me the number of rings, and the group number tells me the number of valence electrons, the electrons in the outer energy level. Those are all notes that everyone should have taken on Friday. And for those of you who were not present on Friday, you can learn from this now. All right? So you go about using your legend that you created to color code the particles, the subatomic particles. All right. So we said that the period number indicates the number of rings. So this hydrogen is in period 1, so I draw 1 ring. So I drew 1 ring. All right. Then the group number tells me the number of electrons in the outer energy ring. So the outermost ring should match up with the number of electrons with the group number. All right. So this is group number 1. So in the outer ring, which hydrogen only has 1 ring, that's why it's so light, we just have the 1 electron. All right. And then number of protons in the nucleus, 1 proton. All right. So we are done drawing hydrogen. So let's look at helium. Helium is element number 2, so that means its atomic number is 2. You'll find that on the periodic table. Take the mass. Well, okay, so atomic number is 2, so go ahead and fill in your protons and then fill in your electrons. Protons and electrons are going to be the same. We're not doing any ions. We're only doing neutral atoms. So protons and electrons will be the same number. Then take the mass, which is 4, minus the number of protons to get your neutrons. So 4 minus 2 equals 2 all day, every day. So now we have our numbers. So now I know what all I'm putting inside this atom. Now, what period is helium in? It's in period 1. That identifies the number of rings. So I'm only drawing one ring. Okay? Now, helium is a bit of something that you have to remember about helium is it's special in that it's in group 18, but it only has 2 valence electrons. So it's not going to have 8 valence electrons. So just like any kind of language arts rule, there's always those exceptions to the rule. The only reason that there's an exception to this rule is it only has 2 electrons. It behaves just like everybody else in the noble gases. It does not react with other elements under natural circumstances because that energy level is full with 2. You cannot put any more electrons on the first ring. They're too close to the nucleus. It would cause what chemistry calls entropy, chaos and disorder. So we have one ring because it's in period 1, and it has 2 electrons on that ring because it only has 2 electrons. It can't have 8. All right? So how do I figure out what to put in the nucleus? I go back up to my number of protons and neutrons because protons and neutrons are in the nucleus. That's where the mass of the atom belongs. So I drew 2 protons and 2 neutrons in the nucleus, as you can see right there. All right. Moving on to lithium. We're going to use lithium 7. All right. So lithium is the 3rd element. It has an atomic number of 3. So I put the atomic number right here. Now, that tells me the number of protons and the number of electrons. So I can just automatically fill those numbers in. Then I look back at the mass and subtract the protons because mass minus protons equals neutrons. So 7 minus 3 equals 4 all day, every day. All right. Find lithium on your periodic table, and you will see that it is in period 2. It is the first element in period 2. It is in group 1. All right. So being that it is in period 2, that tells me I need 2 rings. 1, 2. 2 rings. 1, 2. Okay. So, excuse me. So all of the atoms, all of the elements, their atoms have 2 electrons on the first energy level, except for hydrogen because it only has 1. So once you get past helium, you automatically, that first ring, put 2 electrons. Once you get from helium on, draw that first ring, put 2 electrons, and then start working on your other rings. All right? So lithium is in group 1, so it should have 1 electron in the outer ring. And that's exactly what it has there. So I should have 3 electrons. 1, 2, 3. So I have my 3 electrons. Now I go back and figure out what I'm supposed to put in the nucleus. Well, I'm supposed to have 3 protons, so I put them in the nucleus. And I should have 4 neutrons and put those in the nucleus. And now lithium 7 is complete. So boron, mass of 11. Boron is the 5th element. So its atomic number is 5. Knowing that, I can fill in the protons and I can fill in the electrons. I take the mass minus 5 equals 6. So there's my neutrons. Mass minus protons equals neutrons. It is in period 2, therefore it has 1, 2 rings. It is in group 13. Now this is what we didn't get to on Friday. This is a piece of new information. Group 13, well, it's just easier to say it this way. There's 10 transition groups, transition element groups. Remember, 3 through 12? So there are 10 groups that are considered transition, and they kind of break these rules, and you would just have to know when you would put how many electrons, valence electrons, in the outer energy level. Mostly because they're very metallic, and they do metallic bonds, which are overlapping bonds. So we're not there yet. So just realize that, follow this rule that I'm going to tell you. Group 13 will have 3 valence electrons. Group 14 will have 4 valence electrons. It's because the pattern of the transitions accounts for 10 electrons, okay guys? So you're just ignoring the 10 spot. Group 15, guess what? 5. Group 16, you know it, 6. Group 17, 7. And group 18 will have 8, except helium, because he only has 2. All right? So now I'm back up here to boron. Boron is in group 13, so it will have 3 valence electrons. Let's count them. 1, 2, 3 valence electrons. My total electrons needs to be 5. Do I have 5? 1, 2, 3, 4, 5. I do have 5. All right. So I've accounted for all my electrons and I've placed them in the right positions. Now I need to fill in my nucleus. I need to have 5 protons and 6 neutrons and put those in the nucleus. So there's how you complete boron. So in your e-learning through eBackpack, I have attached the back side for those of you who were not at school on Friday, or for those of you that didn't take it home. I am submitting it to you in eBackpack so you can complete carbon 12, nitrogen 14, oxygen 16, and neon 20. You will have to know the new information about group 13 has 3, group 14 has 4, group 15 has 5 valence electrons, 16 has 6, 17 has 7, and 18 has 8 valence electrons. Have fun with it. If you're not going to use the same legend that I have for colors, make sure you create the legend. Don't forget to create it. Even if you are using my colors, make sure you create the legend so that it can be graded properly. All right? Well, good luck. Have a good day. It's pretty slick out there, so I'm hopeful that you don't have to get out and about, because obviously it's not very pleasant out there, or we would have gone to school. Have a great day. Send me an email if you have any questions.